Watch, learn, and we'll be a star freelancer. 24-hour live stream. Save time and money. 100+ free videos and free books with source code, materials, and resources. starfreelancer.eu.
Welcome back. In this lecture, we are going to verify our cluster and then node groups and then nodes, all those things in different steps. Okay. So our first step is to verify our node group subnets, which means like whether this respective node group is created in public subnet or not. So let's go ahead and then verify that. So how we are going to verify is nothing but for the subnets associated for our node group, if we have the internet gateway route, which is nothing but it is present in the public subnet. So let's go to EC2 in the sense like our management console, and then go to Elastic Kubernetes service. So we can see the cluster with the EKS demo got created. Inside that, if we go to compute tab, we can find our node group, right? So EKS demo 1 ng public 1. So it has desired size is 2 nodes. Okay. So let's open that, and if we see here, it has the subnet here. Okay. So we'll click on any one of the subnet. It will open our VPC subnet section here, and inside that we are going to verify. We are going to go to respective route tables and then verify. Okay. So here is the route table, right? In subnets, in the route table tab, you can see that we have the internet route enabled with the internet gateway, which confirms that our respective node group is created in the public subnets. So that is our first step. We have verified. So now verify cluster node groups in EKS management console. That one also we have verified. So we went here and then we have seen our cluster configuration here. We can see the API server endpoint here for our respective cluster, which is nothing but Kube API server endpoint. And this is our OpenID Connect provider URL. So, and in addition to that, in compute, we have seen the node groups, and then inside node groups, we have seen the subnet and all those stuff. And it also created an auto scaling group for this. And why? Because we have enabled the ASG access, which is nothing but auto scaling group access and all those stuff. Automatically, it will create anyway with EKS CTL. We really don't need to worry about those things. So let me close it here. This is the auto scaling group it has created. So using the cluster autoscaler concepts based on the resources we are going to use, we can increase or decrease these things. So we'll see at that respective time. So let's close these things and then go back, and we can see the networking information for our cluster, and then logging information. By default it is disabled. If you want, we can even enable it. We can, as this is EKS CTL managed cluster, always it is recommended to use EKS CTL to enable logging, disable logging, whatever the modifications we want to do. Instead of this management console, if you do it via EKS CTL, that is a good option for us. Okay. And any updates, currently it is using latest. We really don't have any latest updates here. So that's about on a high level for verifying the cluster node group and then cluster. And now to list the clusters, we have already seen EKS CTL get cluster or get clusters. Okay. So if you want to verify the node group, means like under this cluster, you can copy and then provide the cluster name here, and then you get the node groups present inside this. Okay. Get node group and hyphen cluster. So I'll correct that. So this should be like this. Okay. And I'll correct that command. I have corrected it. So now list nodes, you have already seen that kubectl get nodes hyphen o wide. So you can see this. And another thing is kubectl config view minify. Okay. So to see our config context. Okay. So our respective EKS demo 1's config context we can see here. The current context is kalyan@EKS demo 1 US East 1 EKSCTL.io. So this is the current context. So to see the current context of your kubectl, you can use this command. So the next thing is worker nodes IAM role and list of policies. So if you remember in EKSCTL, right, in EKSCTL create node group hyphen help, you know that you have added all these add-on flags, right? So which is nothing but we are going to provide respect to IAM policies for our worker node IAM role. So let's see that now. So let's go to EC2. These are core fundamentals, and then it might take close to 30, 40 or 45 minutes to create your cluster, but it's very important to know what is what before going and then deploying the workloads. So that's the reason we are taking little bit of time. Instead of that, just executing 2 commands our cluster might have created, but we need to understand deeper. So if you see it here in our EC2 instances, 2 instances got created which are nothing but worker nodes, and inside that if we go here we should find the IAM role, right? So you can see that IAM role is EKS and then cluster name hyphen node group. Whatever you see with node group, it is nothing but the node group related node instance role. So if I click on that, so it will open the respective IAM console and then that respective role. So let's wait for it. Okay, so now if you see here, so by default worker node policy, container registry read only, if you see here you have additional stuff here. Okay, so policy for ALB ingress, policy for app mesh, policy for auto scaling, policy for DNS which is nothing but external DNS, and you have also policy for container registry read only and then container registry power user which is nothing but ECR full access, elastic container registry full access. So all these policies got added for our worker node IA, means like worker nodes IAM role. So why this is required? This is nothing but whatever the pods, Kubernetes pods you are going to run in your cluster worker nodes, they need to access it. They need to access these resources, which is nothing but if we want to access the elastic container registry to download the container image, so then it needs access. And then you have 2 ways to do it. So one is create a Kubernetes service account and then create a IAM role and then associate them together and then provide that information for your respective pod, means like for your respective container, so that it can pick up and then use that. So other way is like directly give it in your respective worker node IAM role, so that these worker node, whatever the pods running on this worker node will have access to these resources. So the pods running on these worker nodes will have access to these resources to perform the action. For that purpose we can do this way. And we are also going to do the other way is like create a IAM role, create a policy and then create a Kubernetes service account and then associate everything together. All those things we are going to do it separately for ALB ingress controller and for external DNS, and for multiple things we are going to anyway do it. So let's go there, and then we have seen the IAM role. Also see the security group associated to worker nodes. So let's go here, and before going to security groups, first we'll see the CloudFormation stack and then we'll go back to security groups. Okay, so we'll go to CloudFormation, right? So let me click on this, and why we are seeing here is like what is happening. I just executed that command and then what happened we need to know, right? So now if you see it here, you can see these 2 are the things which has been created today. So today is 14/6/2020, and then as part of this what it created is EKS-CTL EKS demo 1 cluster. So whenever you have executed the create cluster command, it has created the cluster, and the associated events you can see here what all it has created, right? So it will be creating lots of stuff. It will create the NAT gateway, it will create route tables and lots of stuff it will create underlying. Okay, and what are the outputs of that and all these things you can see. So this is your endpoint. Endpoint is nothing but your Kube API server endpoint, right? So this CloudFormation stack, whenever you say EKS-CTL create cluster, automatically it will post the content to the CloudFormation API, and using that it creates, means like using CloudFormation only it has created. So now you also need to see one more thing here. Important thing is NAT gateway. So why? Because if you deploy your worker nodes, means like your workloads in the private subnet and your node group is in private subnet, it needs access to the EKS cluster, which is nothing but control plane. In addition to that, your pods also need to have access to Docker Hub or anything, right? So for that purposes, NAT gateway outbound is going to be helpful. So by default, it will create a single NAT gateway, and you have options to create high availability NAT gateway or even disable the NAT gateway, right? So these are important things which we need to know. So on a high level, I'm trying to explain, and whenever we go to those respective sections, we'll get in detail. So the next section is security groups, right? So before going to security groups, we'll also complete the worker node using key pair kube demo, right? So let's go to our EC2, right, and see what is the key pair associated to it. So ideally it should have kube demo, right? So let's go here, come down. See the key pair name it is associated is kube demo. So let me go to my SSH and take the public IP of any of these nodes. I have took one, okay, and then I will say SSH -i, and I have my kube demo PEM file here, and then I'm going to say EC2 user @ and it should allow us to log in, right? Right, I have logged into the EC2 user with 192.168.42.229 is my private IP, right? And then I can even see my disk space, okay, on the server, right? So it has mounted 20 GB, whatever we said, right? So 20 GB it has mounted for us, okay? So this is about the login to our respective worker nodes, okay? So I'll add this command in the doc. Now let's go back to the security group step, okay? So any security group which has the remote in between it, that is nothing but the security group related to inbound access to our worker nodes, okay? So in this, if you see here, you have the cluster security group and you see something called remote access, okay? So this is the security group we are interested in, right? So let me open that security group here, and in the inbound rules, it is open only to 22 to the internet. So that's the reason just now whatever we have done, the terminal access is worked SSH -i, right? So now what we are going to do is we are going to add one more rule here. So that is nothing but all traffic we are going to allow from anywhere. So for our testing initial sections, we are going to use the node port service for the workloads we are going to deploy. So for those workloads, if we are going to use node port service, then node port generates different dynamic IPs. Dynamic ports. So our cluster public IP means like our worker nodes public IP : and the dynamic port whatever it generates. So using that we should be able to access our applications. So for that purpose this rule is required. So I'm adding this rule here, okay? So which means like I'm saying that adding an additional rule, all traffic from anywhere is allowed for my worker nodes. That's the step 6, okay? So this completes the creation of EKS cluster and then associating EKS cluster to IAM OIDC provider and creating the node groups and verifying everything step by step. So in our next lecture, we'll focus on other section. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about EKS cluster pricing from our learning perspective. So which is nothing but if we create the cluster and then if we leave it, then it is going to burn a lot of money for us. So very important thing about EKS pricing is like EKS is not free like many of the other AWS resources. Irrespective of if we have created our account in the and we are in the first year of our AWS account or it is an old AWS account. So in short, no free tier for EKS. So EKS cluster pricing. Cluster pricing is nothing but the control plane pricing, okay? So we pay $0.10 per hour in US East 1 North Virginia region. All these are related to US East 1, okay? And it might vary based on different regions, but if we get an idea about what is the costing, accordingly how we want to create it and then use it, we get a fair idea, right? So that's the reason. So per day, if we keep running this control plane continuously, then it is going to be $2.4. And if we run it for 30 days, then it is going to end up with $72. So which is like not good if we run continuously and then delay it and then leave it open, right? So that's the reason when we are learning as part of this course, then we need to quickly delete and then recreate whenever we are using it. So in our next section, we are going to do that, means like how you are going to delete your cluster and then how you are going to again recreate it. Again, you can follow the same steps of whatever in our previous section. But the whole idea is you need to, whenever you are working on it, create it, and then whenever you are not working on it, clear it. So that is the good option. So this is about the cluster pricing and worker node pricing. If we take one T3 medium server itself, we will end up with $30 per month if we continuously run it. And these worker nodes are running in the Kubernetes, right? So there is something called they cannot be stopped. Only you can delete your node group and then your T3 medium servers will be terminated. But you cannot stop the instances like regular EC2 instances like stop and then start. So if we take 5 days to complete this course, and if you run one EKS cluster and 2 T3 medium servers, already you will end up with $25. If it is full day it is running, means like 5 days into 24 hours it runs, it is approximately around $25. So considering all these cases, we need to ensure that how we are going to plan, right? So if it is an organization related account and then you are working for some organization and their account you are using, that's fine. But whenever you are trying to use your own accounts, then you should be very careful about the pricing. Even if you are using the Fargate profile also, it has a dedicated pricing information here you can refer. So 2 important points here is, if you are using your personal account, then ensure you delete and recreate clusters and worker nodes as and when needed. In our next step we'll see that. And in important note 2 is, we cannot stop EC2 instances which are in Kubernetes cluster, unlike other EC2 instances. So we need to delete the worker nodes or node group if we are not using it during our learning process. Okay, so that's about it. So in our next lecture we are going to see how we are going to delete the EKS cluster, right? Until then, bye bye. Thank you. Welcome back. In this lecture we are going to look into delete EKS cluster and then node groups section. Okay, so let's go into 0104 and we have the steps here. Before going into the steps, we need to understand one thing thoroughly. Okay, so one thing, that is nothing but you have created your cluster and then node groups using EKS-CTL, and whatever the objects it has created as part of EKS-CTL, if you are going to edit any of those things, then we need to ensure that we need to roll back. Example, just now we have added one rule here in the EC2 management console for this security group, which starts with the remote, means like which has the EKS-remote access, right? So for this, what we have done is like we have added the all traffic here, correct, right? Which means, so whenever you are planning to delete the cluster and then respective node group or whatever it is, right? So roll back this change, which is nothing but go here, edit inbound rules, and then remove these 2 rules related to all traffic and then leave it as the previous state. And then you can directly go and then delete the cluster, which will also delete the underlying node group. First it will delete node group and then all the node groups under that cluster, and finally it will also delete the cluster control plane too. So that is, within one command you can delete everything after rolling back your changes. So this is the note 1. And note 2 is, in our future sections, whenever we are doing the storage section or anything, we will also go and then update our worker nodes IAM policy, which is nothing but whatever we have seen here, right? So if you go to instances and if you click on this IAM role, right? So inside this we are going to add the role related to, we are going to attach a role related to CSI driver, means like EBS CSI driver related policy we are going to associate. So if that is the case, if you go and then again directly delete the cluster after your work or anything, again it is going to be in trouble. So that's the reason, whatever manually you have edited the objects created by EKS-CTL, please ensure that you revert them back and then do the next step of deleting the cluster. If not, what is the problem, right? So if not, what is the problem, we'll see in a little bit. But for now, if you want to delete both node group and then cluster, you can use you can directly use EKS-CTL delete cluster and then cluster name, so that first node group will get deleted and after that it will also delete the cluster. And if you want to only delete the node group, so then you can have like this, EKS-CTL delete node group and the cluster name and the node group name, and then it will delete the node group first, and after that you can even go ahead and then delete your control plane, which is nothing but the cluster. So now one thing we are discussing is what happens if we don't revert back these things, right? Whatever we have edited the objects which was created by EKS-CTL. So what happens is, some of the CloudFormation events will fail here during the deletion. So you need to cross check what it failed and then go and then manually delete them and then work on it, or again try to delete from CloudFormation stack and ensure that whenever you click on the delete, automatically it will say that exclude this item. So check that box and then exclude and then delete it, so that you will be able to delete. But very important thing here is, as part of this cluster, it creates one NAT gateway which is already getting priced, right? In addition to that, it also creates one network load balancer which is in the pricing state only. And it also created a lot of other stuff, which means like per day it is charging $2.5 for this cluster control plane. Considering all those things, we should know how to delete this stuff, which means like how to ensure that we have deleted our cluster thoroughly after our work is completed. So for considering all these things, I have ensured that. So this section is added for you with 2 important notes here. Let me come here, and so here, okay, so note 1 and then note 2. Like this, whatever you change, means like if you change something, if I change anything over the course, I'll add that here. But if you go and then change something, please ensure that you remove them and then after that delete, so that you don't run into issues. So that is the thing. So in our next lecture, we'll focus on other stuff. Until then, bye bye. Thank you. Welcome back. In this section, we are going to primarily focus on Docker fundamentals. So what are the topics involved in understanding the Docker fundamentals? Let's go ahead and then see that now. So we are in our github.com/stacksimplify git repository. So in that, there is one repository called Docker-fundamentals. So if you go inside, we have 5 sections involved in this understanding and then learning the Docker fundamentals. Okay, so we are going to first understand what is Docker, and then in traditional approach, what are the problems we are having, and then why with Docker, how we are going to solve it, and we are going to understand the Docker terminology or Docker architecture. So once all that is covered in first section, then we'll move on to the Docker installation. So in Docker installation, we'll focus on installations on Windows, Mac, and also troubleshooting Docker desktop issues on Mac. So from there on, we'll move on to 2 major flows which are more essential for understanding the Docker. So the primary flow is like pull a Docker image from Docker Hub and then run the Docker image as a container. So we have existing Docker images available for different applications, and then how we need to pull that and then run it on our local Docker machine, we are going to see it. In addition, the flow 2 is like build a new Docker image and then run it locally and then again push it back to the Docker Hub. So how we are going to do that? So if we understand basic these 2 flows, so we are very good with the Docker, in the sense like we got the fundamentals thoroughly. In addition, we'll also focus on essential Docker commands. So the Docker architecture, what we are seeing, already covered in Docker introduction. So we really don't need to worry about it, okay? But the core thing is we are also going to focus on essential Docker commands on day-to-day life, what we are going to use when we are using the Docker. So this is the core things we are going to perform now. So I'll see you in the next lecture with the Docker introduction. Until then, bye-bye. Thank you. Welcome back. So in this lecture, we are going to focus on 01 Docker introduction. So as part of Docker introduction, we are going to see what problems we have with the current traditional infrastructure and then how Docker is going to solve them. In addition, what are the advantages of using the Docker we are going to look into. So for presentation slides, you can click on this link and then view the presentation slides. So the slides, whatever we are showing in these lectures, is also available here for you for download. So moving on, so if we go to the 01 Docker, so we have something called Docker architecture, right? So in addition to Docker introduction, we are also focusing on Docker architecture. So Docker architecture is like a series of terms in Docker introduced, which we need to be aware of to understand and then play with Docker effectively. So what is Docker daemon? And then what is Docker client, or what are Docker images, and then what are Docker containers, and what is Docker registry or Docker hub. So all these terms, whatever is introduced in Docker, so we are going to understand as part of the Docker architecture or Docker terminology section. So let's go back to our introductory slides and then move on with the stuff. Okay, so in Docker introduction, so first thing is what problems we have with the traditional infra. So let's see what are the problems we are having. So in the traditional infra, we have the hardware infrastructure. On top of that, usually we install our respective operating system like Ubuntu or SUSE Linux or Red Hat or CentOS, whatever it is. And then when we are planning to deploy our applications, its equivalent OS level libraries we install and also its equivalent dependencies we install. So let's consider we have web servers as Nginx and then app servers as some Spring Boot applications which are of Java type, and then we also have databases as MySQL. So for those things, what are the OS libraries required? We need to install them, and then also the dependencies. Example, if you want to run some JBoss or Tomcats, then you also install the JDK and all those things, right? So like this, what all dependencies of libraries and dependencies are required, we need to install and then handle them. So now if you see, installation and configuration will be a biggest problem in the traditional approach. Okay, so it is going to be time consuming, and we need to perform all these library install, dependency install, and then these vendor product installs, all these things across our environments like dev, QA, staging, and then all the production environments. So multiple times we need to implement them. But when you consider Docker, so from Docker perspective, package it once and then leverage it or use it across all the environments. So one time work, and then after that everything is like packaged and then it can be leveraged across environments. Compatibility and dependency, right? So we need to keep resolving issues related to libraries and then dependencies continuously. So if we do the OS upgrade, then what happens? Again, the libraries, some libraries might break, and then we need to fix those libraries, or we need to fix the dependencies, or we need to upgrade the dependencies. So like that, we face multiple issues from compatibility and then dependency issues when we are on the traditional infra, and inconsistencies across environments. So if you have multiple 5 dev environments, 5 QA environments, 5 staging environments, and 2 production environments, it is very hard to track changes across these environments, and they end up with multiple inconsistencies. But when in Docker, if you package it once and leveraging it across all the environments, so then there is no chance of missing or having the inconsistencies in our Docker images. Operational support. So we need more resources to handle operational issues on a day-to-day basis, because of you are going to scale your hardware infrastructure heavily to support your operating system and the needs from your environment's perspective, right? So the server support, hardware, and then software installations, and then patching releases, all these things we need to spend a lot of money and then lot of resources to handle all those things. When it comes to Docker, all these things will be simplified. So in addition, developer environments. So when a new developer joins the team, the time it takes to provision his development environment in traditional approach is time taking, and even most of the time it will not be 100% right. But when we consider our developer environments are Dockerized, then it is going to be a minute or less than a minute to provision that respective developer's environment. So all these problems, whatever we are seeing in traditional infra, can be easily solved using Docker. Moving on, so let's see how a physical machine looks like when we install the application. So we have hardware infrastructure, operating system, libraries, dependencies installed on that operating system, and we have deployed the web servers, app servers, and then databases on that physical machines. So let's see from physical machine to virtual machines, what is the difference, right? So we have the hardware infrastructure, and in virtual machines we'll have the hypervisor, and on hypervisor we create the virtual machines. So we have the operating system for each virtual machine, and then we'll install the libraries and then dependencies for those virtual machines, and then we'll have the equivalent containers, equivalent vendor products installed on those virtual machines. Okay, so now if you see here, this is a little bit simplified version from the physical machines, but still the libraries and then dependencies and then all these incompatibility issues still going to be there across environments, and then you need to solve these things. But in virtual machines also there is a concept of creating a virtual machine image and then leverage it across environments. We have seen that, but still with IP address changing, DNS name changing, and then lot of other things we need to bring into the picture when we are even using the virtual machines OVA images or whatever is it. Okay, so moving on to Docker. So when it is installed on a physical machine with Docker, it is going to look like this. Okay, so we have a hardware infrastructure and we have the operating system. On that we are going to install the Docker, and then we are going to run the containers. So each container is a combination of its own libraries, dependencies. It will have its own operating system inside that, and then we'll be installing the Nginx or even the app servers and then databases, whatever it is, they'll have their own libraries and then dependencies, so that once and for all we are solving the libraries and dependencies, and then we are going to package and then use that Docker image across all environments. So if you see here, so on the operating system, we are going to install the Docker. In the same way, if you see virtual machines with the Docker, so we have the hardware infrastructure, we have the hypervisor, and on that we are going to have the operating system for that virtual machine, and then we are going to install the Docker, and then from there we are going to deploy our Docker images as containers on them. So we can run multiple Docker containers in a single virtual machine, right, based on the memory and then CPU limits, whatever we have. So like this, you can run 100 containers or 200 containers, all those things. So nothing, there is no dependency from our perspective, from either hardware infrastructure or hypervisor perspective. Okay, so if this respective operating system is allocated with equivalent CPU and then RAM, and then if those are minor containers, then you can run any number of those things. Okay, so but with that said, the core thing here is like Docker is flexible for us. The way how we want to use it, we can use it in a better manner. Moving on, so what are the advantages of using Docker, right? So why containers? So they are flexible. So even the most complex applications can be containerized in our recent days. So they are very lightweight, and containers leverage and share the host kernel, making them much more efficient in terms of system resources than virtual machines. So they are very portable. So you can build locally, deploy to the cloud, and then run anywhere. So they are very loosely coupled. These Docker images or Docker containers are loosely coupled. Containers are highly self-sufficient and encapsulated, allowing us to replace or upgrade one without disrupting others. So they are very much scalable. You can increase and automatically distribute container replicas across a data center. So they are very much secure. Containers apply aggressive constraints and isolations to processes without any configuration required on the part of the user. So with that said, the Docker containers are flexible, lightweight, portable, loosely coupled, scalable, and then even secure. So now moving on, we'll be looking into the Docker architecture in our upcoming lecture. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So let's see the Docker architecture now. So, or even we can call it as Docker terminology. So we have a Docker host, and inside Docker host primarily we'll install the Docker daemon. So the Docker daemon, Dockerd, listens for the Docker API requests and manages Docker objects such as images, containers, networks, and then volumes. So the next is the Docker client. Okay, so Docker client is an optional thing in the Docker host. So we can either install on the Docker host or on our own desktop, and using the Docker client we will be able to communicate to the Docker daemon. So Docker client can be present on either Docker host or any other mission. So the Docker client, Docker is the primary way that many Docker users interact with the Docker. So when you use commands such as docker run, the client sends these commands to Dockerd, which is nothing but Docker daemon, which carries them out. So the Docker command uses the Docker API. So the Docker client can communicate with more than one respective daemon. Okay. So moving on, the next thing is the Docker images. You can see here the image 1 and then image 2. So an image is a read-only template with instructions for creating a Docker container. So often an image is based on another image with some additional customizations. So example, like we may build an image which is based on Ubuntu image. So we already have a Ubuntu image, and then consider that image we are taking and then building our own image using that Ubuntu image. So with that Ubuntu image we install additional application options of what we are planning to use, which is like Apache web servers or Java, JDK, and then additional Tomcats, whatever we want to install, and then deploy our application inside that, and then package it as our own application image. So the base image there we are using is the Ubuntu image. So that is called image is based on another image. So moving on from Docker images, the next thing is the Docker containers. So a container is a runnable instance of an image. So we can create, start, stop, move, or delete a container using the Docker API or CLI. So we can connect a container to one or more networks, attach storage to it, or even create a new image based on its current state. So when a container is removed, any changes to its states that are not stored in persistent storage disappear. So that's most important point from containers perspective. So moving on, so let's see, we have a Docker host, and on Docker host we have the Docker daemon. So if you want to pull the image and then run it as a container, so what's the process going to be? Let's go ahead and then see that now. So Docker client, it can be my desktop or even the Docker host. So what we do is like Docker client is nothing but the Docker command, DOCKER. Okay. So I'll say Docker pull nginx demos /hello. So one sample image. So what happens is it will go and then communicate to the Docker daemon, and then via Docker daemon, it will go to the Docker registry, right? So from Docker registry, I'll try to pull the nginx demo /hello and then download that image to my Docker host. So from my Docker host, so the image is present here. So now I'm going to run it, right? So to run it, I'm going to say Docker run and then some -port, local port, and then image port, whatever it is there, and then -d and then the complete image name. So whenever I do that, it is going to run it as a container in the Docker host. So what we have done, so first we have pulled the image from the Docker registry and then stored it as images here, and then we have run it, and then now the runnable instance of an image is called the container, which means like the container has started and then application started serving. So now in this overall thing, you have seen client and then host, but you really don't know what is this registry or Docker hub, right? So let's see what is this. Okay, so a Docker registry stores the Docker images. So Docker hub is a public registry that anyone can use, and Docker is configured to look for images on Docker hub by default. So we can even run our own private registry in our cloud systems like Elastic Container Registry, or using Docker hub also you can even run it, means like the Docker provides the software to run it as a private registry in our local data centers. So when we use the Docker pull or Docker run commands, the required images are pulled from our configured respective registry, right? So when we use the Docker push command, our image is pushed back to the registry. So we are going to see two flows. By seeing what we have seen here, the complete thing we are going to distribute into two flows and then implement them in our upcoming lectures. So the flow one is to what we have seen here, like pull our container image here and then run it as a container, right? So the second flow is like build a image here, run it as a container locally, and then test it, and finally push it to the Docker hub. So we are going to see all those things now in a step-by-step manner. I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. So in this lecture, we are going to look into Docker installation. Okay. So from Docker installations perspective, so let's click on the Docker install. And we can see here, so we can install the Docker engine, and then it is supported in different platforms. Okay, so CentOS, Debian, Fedora, and then Ubuntu, and with x86, AMD 64, ARM 64, IBM Power, and then IBM Z series. So this is more or less like a Docker engine directly installed on those respective operating systems. So in addition, we have something called Docker desktop. So we have the server version, and also we have the desktop version. So from server versions perspective, all these operating systems are supported, and these models are supported. Okay, so x86 64 or AMD 64, ARM, all those things. So now from desktop's perspective, So we can install Docker Desktop for Mac on Mac OS and also Docker Desktop for Windows on Microsoft Windows 10. So let's start with the Windows, right? So when we click on that Windows, so you can see here, get started with Docker for Windows. So we can directly install the Docker Desktop on our Windows machine and then test these things using these steps. So let's click on install Docker Desktop for Windows. So we have the system requirements here. Our system should have Windows 10 64-bit, Pro, Enterprise or Education versions, and we should have the Hyper-V and then Hyper-V and containers Windows feature must be enabled on our operating system, means like at the OS level. Okay, so now our mission should minimum have 4 GB of system RAM to operate or run this Docker Desktop, right? So once those are ready, so we can download the Docker Desktop installer.exe and then run it. Okay, so we can start the Docker Desktop and then we can start using it. Okay, so you can see here, and then you can run the Microsoft PowerShell, and then from there you can run the Docker run hello world, right? And then you can test it. So in addition to that, from Docker Desktop only you can even log into your Docker Hub ID. Okay, so that's about the Windows installation. So this Docker Desktop is going to be pretty easy from install perspective if you have the exact system requirements. So primarily, like if your system is of Windows 64-bit and then Windows 10 you are running and at least you have 4 GB system RAM, then it is good. Okay, but from my observation, what I am saying is usually 4 GB system RAM, if you install this Docker Desktop, then your system will be at the disaster. This is the live experience whatever I am having. Okay, so ensure that your system has 8 GB RAM so that you can even leverage that for using other tasks other than Docker Desktop things. Okay, so if it is only 4 GB system, then it only supports for Docker Desktop, and then most of the things whatever you run, either your Spring Boot IDE or Eclipse IDE or whatever you are running there, it is going to be a hell lot of a system where it will be very slow. Okay, so 8 GB RAM is always recommended, even though it says 4 GB here, but in real world it's 8 GB is recommended. Okay, so that's about the Docker Desktop on Windows. Okay, so moving on, so the next thing is Docker Desktop on Mac, right? So if you see here, this is get started with Docker Desktop for Mac, right? So install Docker Desktop for Mac. So let's go there, and then so if you see here, so from system requirements perspective, if you are on the latest OS, it is already supported. So Mac OS must be version 10.13 or even newer. So this is the thing, and 4 GB of RAM, that's what they say as usual, and VirtualBox prior to version must not be installed. So all these things you can ignore. Okay, so for this VirtualBox and all those things. Okay, so directly download the Docker Desktop and then move it to the application folder, and then once you have moved to the application folder, it will be available as a docker.app. Okay, so you can run that, and then once you run this docker.app, so it will start displaying here. You can see it here, right? So Docker Desktop is running on my Docker Desktop, so it will be available for us to run it, means like it will be available for us to open it from here on. Okay, so it's engine version, compose version, Kubernetes version, all these details are provided here. So once our Docker Desktop is up and running on our Mac machines, so we can go here and then go to the preferences section and then ensure that this respective setting, okay, securely store Docker logins in Mac OS keychain. Okay, so this setting should be unchecked. Okay, so I already have a running version here, so I'm not looking into it, but ideally this setting should be unchecked. So let's see more about it. Okay, so Docker Desktop on Mac has an issue with the Mac OS keychain. Okay, OS X keychain. Okay, so to fix it, we need to perform these two steps. So one is go to Docker Desktop changes, open Docker Desktop preferences, which is nothing but whatever we have seen here, right, in preferences, and uncheck the option named securely store Docker logins in Mac OS keychain. So that is first thing. Okay, and once that is done, go to the config.json file in .docker folder. So this will be there in your root folder. Okay, so if you go to your users and then kdaida, my home user is, my user's home is users kdaida, and inside that I'll have a folder called .docker. and then inside that you will have something called config.json. Okay, so currently I removed it earlier, so I am not finding it here, but you will find some line called cred store osx keychain. Okay, so this line, okay, so you just need to remove this and then restart the Docker. Okay, so restart the Docker daemon. So you can see here, you can say restart. Okay, somewhere it should be there here. Yeah, restart the Docker daemon. So when you do that, so this issue will be resolved. If you face any issues related to this OSX keychain, ensure that you are going to troubleshoot when it is on Mac using following things. Okay, so other than that, on Mac you are not going to face any other issues. Only this issue you will face, and then you can fix it using these things. Okay, so in our next lecture we'll focus on our flow one, which is pull from Docker Hub and then run the Docker image. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to pull a Docker image from our Docker Hub and then run it as a Docker image. Okay, so let's go to our Docker Hub account. Okay, so hub.docker.com, and then I have a Docker Hub account here, and let's see the image which we are going to use. So I have an image called Docker intro Spring Boot Hello World REST API. So I'm going to use it. So usually everyone will try to use Nginx. So, but we are trying to use it little different. So to show different things here. So we'll see what are those things. Okay. So let's go to the Docker fundamentals and then pull from Docker Hub and run Docker images. So let's start with the step one, verify Docker version and also log into our Docker Hub from our Docker client perspective, right? So let's go here and then clear, and I'll say Docker version. Right, so it has given my client Docker engine version, which is 19.03.05, and also my server Docker engine version also been provided here. Okay, so let me clear this, and then I'm going to say Docker login, so that I'll be able to authenticate to my Docker Hub account. Okay, so already I have provided the credentials earlier, so that's the reason it is showing. So I can even say Docker logout. Okay, so now it has been logged out. So if we want, we can even log in one more time. So I can say stack simplify. Okay, so my login got succeeded. So if I want anything in config.json, we can cross check. Okay, so nothing related to Mac OS X keychain. Okay, so that means we are good for now. So let me clean this, clear, and go back here. Okay, so now pull an image from Docker Hub. So for that we are going to use just Docker pull, and the image you can see here, whatever is there, you can pull this image, or you can get the image name directly from our Docker Hub account here. Okay, so this is the one. So whatever we want, we can pull it, and here 1.0.0 -release. Okay, so I'll try to copy this complete command from here and then execute it for the convenience. Okay, so let me paste the command here. So now it is going to download. So that respective image is getting downloaded to our local repo. So let's wait for that to completely download. So now it is downloaded. So you have a command called Docker images. Okay, so you can see here only one image, whatever we have downloaded, is available. So there are no other images other than this. So using Docker images, we have checked the downloaded image. Okay, so let me clear this and then go back. Okay, so now run the downloaded Docker image and then access the application is our step 3. Okay, so you see there is a command called docker run to run our image as container on our local desktop, right? So let's see what are the options here, right? So the first thing is docker space run and then hyphen name, and then I'm saying app1. So nothing but this is an optional thing. So what I'm trying to give here is like my Docker container name, I'm going to give it as app1. If we don't give, it is going to auto generate some name for us. Okay, but always it is good to give a Docker container name what we are going to run. So we are trying to use the best practice here. Okay, and the next thing is -p and then 80:8080. So here you see, right, the first 80 whatever you are seeing is your local port, okay, which is nothing but you are going to expose from your local desktop. Okay, and 8080 is nothing but the second one is nothing but your container port. So you are mapping your container port 8080 to your local desktop port 80. That's what you are doing here. So whenever you access localhost/hello, which is nothing but with port 80, your application is accessible, okay, with port 80, even though container port is 8080. So that's the thing. And -d and your container means like the image complete name including the tag value, right? So like this. So let's go and then copy this command now and then paste it and then run it. Okay. So we are going to run it now. So now we are going to see how it is running. Okay, so docker ps is the command to see the list running containers. Okay, so my container is running. Okay, it is created and its status and all those things we can see it here. Okay, so now the container name at the end you are seeing, right? It is nothing but app1 and its pointing is 80 to 8080. You can see all these things here. Okay, so now let's go to the browser and then say localhost/hello, right? So 2 else. Okay, hello world v1, you can see, right? So now whatever we have run it, we are able to access our application. So let's go back here and then list the running containers. Okay, and we have other commands also. If any other containers which is stopped containers are there, we will be able to see them with -a. In addition, we'll have something called q, which will give us only the container IDs. Okay, so if you want to stop the container, then you need just the container ID, right? So you can get that container ID and then stop it, or you can pass this command as input to another command. Okay, so for that purpose -q is used. Okay, docker ps -q is used for passing these container IDs to another commands for doing whatever we want. Okay, so when we are doing the advanced sections, usually we will know all those things. So moving on, so now we can even connect to that container terminal, which is nothing but whatever the docker container, whatever we have created is a Linux container. So we can directly connect to that and see what's going on. So for that, the command is docker exec and then -it and the container name and then /bin/sh. Okay, so this is going to be something called paste, and my container name is app1 and then /bin/sh, right? So now I am in my container and you can see here my app.jar is there, and then lot of commands are going to not work, only basic commands will work. You can see ps-ef, which is nothing but the Java command, whatever the Spring Boot application is running here. Okay, so now we are in our container. Okay, means like inside the container command prompt we are here. Okay, so I'm going to exit and then I came out. If you want again connect, you are in container. Okay, if you say ls app.jar, you are seeing ps-ef, you can see these things. Okay, if I say exit, again I came back. So I came back to my local Mac desktop. So like this, you will be able to connect to your container terminal. So if you want to stop the container, you can stop using container app1, right? So I can say docker stop app1. My container name is app1, so I am stopping it. Okay, so if I say docker ps, right, so no other containers are running. Okay, but if with -a, you can see the stopped containers. So you can see the stopped container you are seeing, you can see it here, exited 143, right? So but without -a, only running containers you can see. So now if you say localhost and then access it, it's not working, right? So now again one more time, it is a stopped container, you are going to start it. So and then say docker start app1. Okay, now your container is running. So when you say docker ps, you are able to see it. Okay, -a will give you the stopped containers, and without -a, you can see the running containers. Okay, so now it is again running. So let's access this and then say, okay, so hello world v1 is coming. That's good. Okay, so now you have completed the container stop and start. Finally, if you want to remove the container, you can say docker space rm and then container name. Okay, so let's do that now. Okay, docker rm and then container name is app1. Okay, you cannot remove a running container. Stop the container before attempting to remove it. So let's go there and then stop it. Now we have stopped it. So if you say -a, you can see that, and then it is in exited state. You can see it here, right? So now I am going to say docker rm and then app1. So now my container is removed. So PS it doesn't show, and even in the PS-A also it doesn't show. Why? Because even the stopped container is removed from my mission. Okay, so with PS it is not showing, Docker PS, or with PS-A also it is not showing. So that's about it. Okay, finally if you want to remove the image, so you can say Docker image and then image ID. No, it should be Docker RMI and then image ID. So let me correct this. So whatever the downloaded image we have, just go ahead and then remove that image. So let's say first Docker images, clear Docker images, and then get the image ID. So this is the image ID. Okay, and then say Docker RMI, which is nothing but remove the image, and then provide the image ID. Okay, so now the Docker image is removed. So let's say Docker images, nothing is displayed. So whatever you have pulled from our Docker hub is not available. So now it is plain empty. So no other images on my local desktop. So that's about the flow. Pull Docker image from Docker hub and then run it. So we have done it in 8 steps, and then all these will be as a reference for you whenever you want to execute. Okay, so you can go to this Docker GitHub account and then use it. Okay, so I'll see you in the next lecture with our next flow. Until then, bye bye. Thank you.